let's finally move on to the division of algebraic expressions. So here we follow just one rule of thumb, and that is we have x to the power n divided by x to the power n. We have x to the power m minus n, where m is greater than n. So that is the rule of thumb that we generally follow when dividing algebraic equations. So first of all, we'll start with an example of division for a monomial by monomial. Let's get started. So let me put an example of minus 24 x squared y cubed z to the power 5 by 6x y to the power 5 z to the power 4. So we can do this by division method or by just keeping them on a bar line. Let me show you. We'll write 24 x squared y cubed z to the power 5 minus, and then we'll divide it by 6x y to the power 5 z to the power 4. I'll write a simple one. So 6 becomes 1. Minus 24 remains minus 4. X cuts out this square. Then we have y to the power 3 cutting out this as 2. And then we have z to the power 4 cut out as 7. So our final value comes out to be minus 4 x y to the power minus 2 z and z. Or we can write it as minus 4x y, sorry, minus 4xz divided by y squared. And that's how we solve it. So this was a very simple one. Now let's try out division by a polynomial by a polynomial. So in this section, we have a couple of rule of thumb that we follow. So let me write that down for you. Okay, so in this rule of thumb, we first need to arrange the terms in the descending order of their degree for both the divisor and the dividend. Then when we are done with that, we first divide the term of the dividend by the first term of the divisor to get the first term of the quotient. Then we need to multiply all terms of the divisor from the first term of the quotient and write these down below the dividend for their corresponding terms and carry out the subtraction like we do in every division. And then we take down the remaining terms and then follow the same route again. This might sound a bit tricky, but when we take an example, this would look a lot clearer. Let's start with an example. So we need to divide 3x to the power 5 plus 7x to the power 4 minus 11x cubed plus 8x squared minus 32x plus 5 by 2 plus 3x plus x squared. How do we get started with that? So because we know we have to divide by, so something that we need to divide by would be our divisor. So let's just write that down. I'll create this simple division thing. And we'll write the divisor in the descending order of their degree. And we'll write the same dividend. So first what we need to do over here, we need to see these two values and check what should we multiply to x squared to get 3x to the power 5. So if we do this, we can either do this mentally or we can write that down and do it. So let me just show this for beginners. So we have 3x to the power 5 divided by x squared. So the x squared cancels out. This gives us 3. So we need to multiply 3x cubed to x squared to get that value. So we'll write that down. So we have 3x squared, x cubed, sorry. Now I'll just write that out, 3x to the power 5. And then we'll multiply 3x cubed with 3x and 2 to get, so 3 into 3 is 9, 9x to the power 4. And then we have 6x cubed. We'll minus this and this will cancel out. Let's put everything as minus. This comes out to be minus 2x to the power 4. And then we have minus 17x cubed. And then we'll put this down here. This comes out to be plus 8x squared. Now we need to find a value such that minus 2x to the power 4 can be divided by x squared. Let's do this here. X squared gives us minus 2x squared. We need to write minus 2x squared here. This gives us to the power 4 minus 6x cubed minus 4x squared. And that comes out to be plus, plus, and plus. So this cancels out. Minus 17 plus 6 gives us minus 11x cubed, and this gives us plus 12x squared. We'll bring down minus 3x, and then we'll follow the root again. So we have minus 11x cubed divided by x squared. This cancels out, give us minus 11x. We need to multiply minus 11x, and that comes out to be minus 11x cubed minus 33x squared minus 22x. Then we bring down 5 over here, and that is plus 5. Reverse the signs. This comes out to be 45x squared minus 10x plus 5. Now we need to find something where 45x squared divided by x squared gives us 45. So we have plus 45. So we multiply it with each element. 45x cubed minus plus 135x plus 90. And this gives us minus 145, 145x minus nearby. So when we divide this value by 2 plus 3x plus x squared, we get a remainder of minus 145x minus 85. That's how we do it. If you find this a bit complicated, you can ask me in the comments down below. And in the final part of this chapter, we have algebraic identities. Let's get started with that. So in order for me to explain it to you, let us start with an example. So let's consider an equation x squared plus 2x plus 3 equal to 38. And let's see if for x equal to 5, this equation checks out. So for left-hand side, we have 5 squared plus 2 into 5 plus 3, which comes out to be 38, which is RHS. Let's check if x equal to 3 gives the same answer or not. Then we have 3 squared plus 2 into 3 plus 3, which gives us 18, which is not equal to RHS. So this shows that this equation is just true for a couple of numbers, and for this scenario it's x equal to 5, but it's not correct for, say, x equal to 6 or x equal to 3 or any other of that value. So therefore we can say that an equation is true for only a certain value of variables in it. But let us consider something else. So let's take an example of x plus 2 into x plus 3, which is equal to x squared plus 5x plus 6. So let's identify x equal to 1 and what is the value of LHS and RHS for that. That is 1 plus 2 into 1 plus 3, which comes out to be 3 into 4, that is 12. Similarly, for right hand side, we have 1 square plus 5 into 1 plus 6, which is equal to 1 plus 5 plus 6, which is equal to 12. So LHS is equal to RHS here. Let's try another value. X is equal to 5. Our left hand side comes out to be 5 plus 2 into 5 plus 3, which comes out to be 7 into 8 or 56. Quickly doing the right hand side, we have 5 squared plus 5 into 5 plus 6, which comes out to be 25 plus 25 plus 6 equal to 56. So here again we have LHS equal to RHS. So here you can see that for this particular scenario, for any x value, the LHS is equal to RHS. And for such equations, we have another name, and that is an identity. So in a very formal sense, an identity is an equality which is true for all values of variables in it. So this can be true for any value of x, as we shown in the previous example. So let me give you some examples of the standard identities. So our first identity is a plus b whole square. And this comes out to be a plus b into a plus b. And we'll solve this out to get a plus b plus b, a plus b. And that comes out to be a square plus ab plus ba plus b square, or a square plus 2ab plus b square. That's our first identity. Let's take the second identity, a minus b whole square. This comes out to be a minus b into a minus b. This comes out to be a square minus 2ab plus b square. Our third identity is a plus b into a minus b. A square minus ab plus ba. And this comes out to be a square minus b. Our fourth and final identity is x plus a into x plus b. And this comes out to be x into x plus b plus a, x plus b. We'll solve this to get x squared plus bx plus ax, ab, x squared plus x, a plus b plus ab. And these are our four identities which we will need to remember so as to get used to all the questions or to be able to do all the questions that we have in this chapter. Let's start with some quick examples. So we'll solve using the identities we have just looked at. Let's solve 2p minus 3q whole square. How do we solve this? So we know a minus b whole square is equal to a square minus 2ab plus b square. We'll use that. We have 2p square, 2p whole square plus minus 3q whole square minus 2 into 2p into minus 3q. This comes out to be 4p square plus 9q square plus 2 into 2 into 3 comes out to be 12p cube. Let's try another question. And this is a bit different, but we'll use the identity, so that would be a lot easier. So let's try to find the value of 98 square. How do we get there? We know that 98 is 100 minus 2. 98 square is equal to 100 minus 2 whole square. And then we can use the identity a square, this identity a minus b whole square, to find the value. So let's write 100 square minus 2 into 100 into 2 plus 2 square. And that comes out to be 10,000 minus 400 plus 4. And this comes out to be 9,604. Hopefully that's quite simple. Let's try another one. So we have 10.3 into 9.7. How do we calculate this? So now first we have to think in terms of identities. What identities look like this? So this looks like something that would resemble a plus b into a minus b, right? So you might not see it, but let me try and show that to you. So we have 10.3 that can come as 10 plus 0.3 and 9.7 that can come out to be 10 minus 0.3. Therefore, we can use this identity. Let's try and solve this. So we have 10 plus 0.3 into 10 minus 0.3. And then we can use this identity that is equal to a square minus b square. That is 10 square minus 0.3 square. And this comes out to be 100 minus 0.09. That is 99.9. These were some of the examples. Let's try something different. So we have the value x minus 1 by x equal to 3. So now we have to find the two values. First is x squared plus 1 by x squared. And the second is x to the power 4 plus 1 by x to the power 4. So let's start with the first one. So given that we have x minus 1 by x is equal to 3, we can also say that x minus 1 by x whole square would be 3 square. So we have x squared plus, we'll expand this to get x squared plus 1 plus x squared minus 2 into x into 1 by x, which comes out to be 9. So x squared plus 1 by x minus 2 equal to 9, or x squared plus 1 by x squared equal to 9 plus 2, that is equal to 11. So that's the value of x squared plus 1 by x squared. Second one is x to the power 4 plus 1 by x to the power 4. So now we have the value of x squared plus 1 by x squared equal to 11. Again, if we square it, we have x squared plus 1 by x squared whole square equal to 11 square. And when we expand this, we get x to the power 4 plus 1 by x to the power 4 plus 2 into x squared into 1 by x squared. That cancels out. And we have equal to 121. So x to the power 4 plus 1 by x to the power 4 is plus 2 is equal to 121. And we can write that as x to the power 4 plus 1 by x to the power 4 equal to 121 minus 2. That comes out to be 119. So that's how we solve this. This is a very simple and common question that comes in the exam, so I hope you are comfortable with it. If you don't understand anything, please do let me know in the comment section below, and please do check out my notes where I have all these answers written for your revision. Let's try another one. So we have a plus b equal to 7, and AB equal to 10. We have to find the value of a square plus b square. So if we know the value of a plus b, we can also say a plus b whole square is equal to 7 square. Now we'll expand this. A square plus b square plus 2ab is equal to 49. So we know the value of a and b, ab, that is a square plus b square plus 2 into 10 and is equal to 49. We can then say a square plus b square is equal to 49 minus 20, and that is equal to 29. So a square plus b square comes out to be 29. Let's try a final question before wrapping up. So we want to find the value of 403 to 405. So we have already done a similar question like this. So we'll use the identity x plus a into x plus b equal to x square plus a plus b into x plus ab to solve this. So basically, we can say that 403 into 405 can be written as 400 plus 3 into 400 plus 5. Now we'll use this formula. So our x here, so to understand x becomes 400, a becomes 3, and b becomes 5. That makes it easier for us. So we'll write 400 square plus 3 plus 5 into 400 plus 3 into 5. This comes out to be 16,000 plus 3,200 plus 15. So this comes out to be 1,63,215. And that's how we solve this. So if you like my videos, please don't forget to like, share, and subscribe for more videos like this. And do check out my notes in the comment section below. Thank you. See you.